Hello everyone, it's me again. Today we have to start carboxylic acid because we just finished alcohol. Remember to do revision. Now for carboxylic acid, what I'm going to tell you is, first I'm going to let you know what sorts of reactions we can use to help producing carboxylic acid. Then I will tell you something about the strength of the acidity of carboxylic acid. I believe that all of you know that it is a weak acid, right? But anyway, we can have a revision. And the core part, of course, are the reactions of carboxylic acid. Basically, regarding the reactions of carboxylic acid, you all know all of them already. There is except one reaction I need to remind you, that is the reduction. For the rest of the reactions, you learned them in IGCSE already. They are exactly the same. So it's not much new for you to catch up here. So it should be easy, okay? Oh, now first, carboxylic acid. Is the acid, the organic acid that contains COOH group, right? And then first we need to know how to prepare it. Preparation, okay? There are three ways for you to prepare it. The first one, of course, the first and the second, I will consider them the same. That is the hydrolysis of an ester. This is what we have learned in the previous chapter, okay? It's acidic and alkali respectively, right? Now for acidic, right? For acidic, how can we prepare it? If you remember, we basically have to, for example, if you have an ester like that, then as what I told you yesterday, you hydrolyze it in acidic medium. This bond will be broken, then it will become like that, right? And together with the alcohol, then you can get the acid. Can you see that? You can get the acid. You can get this acid, right? So this is the first reaction that we can produce acid from ester. But since this is a reversible reaction, so the problem that we face when we use this method to produce carboxylic acid is the yield is not good, right? Because we all know that if this is a reversible reaction, even though it attains equilibrium, both the reactants and products will coexist. And of course, you cannot 100% turn your ester into carboxylic acid, and this results in a poor yield, right? So that's why if you really want to use hydrolysis to produce carboxylic acid, most of the time we prefer alkaline medium. But as you know, if you do it in alkaline medium, you will get the carboxylate ion instead of carboxylic acid. But it doesn't really matter because at the end of it, you can acidify the carboxylate ion to acid again. Okay, so for example, I use the same ester. Okay, then in alkaline medium, I heat it. This bond is broken, then you will get this one, the carboxylate ion, negative, together with the alcohol. Okay, now for this carboxylate ion, if you add a few drops of acid into it, it can be acidified back to carboxylic acid very easily. In this way, the yield is good. You just have to do one more step, that is acidify. Okay, to acidify the salt. Okay, because it is a complete reaction, so basically you can successfully convert all the acid all the way to carboxylic acid. Okay, cool. Now then the third reaction is hydrolysis of a nitrile. Okay, now this is also very easy. You just turn the CN. When you boil it in acid, reflux, or heat it, this group will become COOH. Okay, so I give you an example. Sorry. I give you an example. If you have this one, what you need to do is to just heat it in acid. Then this group will turn to COOH. Okay, And this is the way how we prepare carboxylic acid, because sometimes the questions may ask you, give two ways of preparing carboxylic acid in the laboratory. We have acidic hydrolysis of an ester, but the drawback is you cannot 100% convert the ester to carboxylic acid because it is a reversible reaction, okay? And then you can also consider alkaline hydrolysis, but instead of getting the carboxylic acid directly, you will have to acidify the acid, okay, at the end to turn the salt, the carboxylate ion, into acid. This is ethanoate ion, right? Into ethanoic acid by adding a few drops of acid, okay? If you don't like this method, you can simply use a nitrile. You just have to heat it up in acidic medium, then it becomes carboxylic acid, okay? 好，嗱等啦，let me tell you the acid, carboxylic acid. Now normally when the organic acid contains COOH group, it is a weak acid. So do you remember what weak acid means? It means it can only partially ionize, or you can use the word dissociate in water to form hydrogen ion, right? So normally we use a reversible arrow to represent what's going on, okay? Which means that when it attains equilibrium, as what I said for so many times, both the reactants and products are the same. So for example, if originally this is 100, 0, 0, but in the end maybe this is 95, still 95% of the acid maintained in a molecular form, and you are just able to turn 5, okay, to the right side, okay? But it all depends on the acid's dissociation constant. This is what we are going to talk about in A2, okay? So, understand? 好，嗱 then we go back to the notes first. Go back to the notes. Notes E. Okay, let's just fill in the blanks first, okay? Hydrolysis of a nitrile, when a nitrile CN, okay? It's refluxed. Reflux means you need to heat it up with dilute hydrochloric acid, a COOH will be formed, okay? And the CN group basically will change to COOH. Now you don't have to know the mechanism, so I don't want to spend time on talking about it. But of course, if you're really interested, you can go to the internet and find the mechanism. It's very easy to find, okay? So forming a carboxylic acid, okay? So generally, you're doing an alkene nitrile. So you heat it in acid, it becomes carboxylic acid, or you can call it alkenoic acid. They are the same, okay? So, for example, if you have CH3CN, then you heat it. So what will be formed? What will be formed? Give you 1 second. Okay, the answer is COOH. So basically, the only change is this group. It's changing to this group. Before and after, they also contain 2 carbons. So it's different from nucleophilic substitution of halogenic alkene. If you remember, for that reaction, you can increase the number of carbon by 1. Keep quiet, Muji. Okay, hold. Oh, there is a chemical equation. Can you write this? And you can also write a general one here. So COOH, okay? Carboxylic acid are weak because their molecules do not ionize. Or you can use the word dissociate. They are the same. When added to water to form hydrogen ion, you can add this into the notes. Hydrogen ion, okay? However, a small proportion of the molecules do dissociate, releasing hydrogen ions, right? That characterize or acidic solution with a pH value of less than 7. This is what we learned in Form 3, okay? So, example is ethanoic acid. When it dissociate in water, it forms hydrogen ion. Or you can present it like that. If you add water into the equation, it will come up with H3O+. Basically, they are the same. Because once the hydrogen ion is formed, it's going to form a dative covalent bond with a water molecule to form H3O+. So they are the same. They give the characteristics of acid. Okay. Oh, let me stop here because I can't make it longer than 15 minutes.